Okay, let's go ahead and get started on everything, everybody. But I'm a little late for the stream, but I'm here. Um, so welcome in for the 2 p.m. PST Twitch stream. I'm your host, Transfer Jim, and today's lineup, we got our well, not quite an hour's of Pega lined up. Then we got an hour of video uploads to do. And then after all that is said and done, then we got Final Fantasy VII later on tonight. So we got a little bit of a, um, we got quite a bit to kind of cover today. So let's get right into this, shall we? So um, first thing that I want to say is what I normally say during these Pega um, intros, videos, what have you. Um, this is not endorsed by Pega whatsoever. Me and them are not like, getting. Well, I mean, they might be getting some benefit, like, out of these videos. I don't know. Um, but there's no benefit coming towards me or anything along those lines coming from Pega. Okay, so if you're thinking that, oh, this is like a paid promotion, blah blah blah, or something like that, no, get rid of that. Okay, this is my attempt to get through the certification. You know, my aim is to get the certification for the system architect, um, and maybe get the business architect as well. But the main aim is the system architect. Okay, for the certification. Um, Second thing I want to mention, okay, is that I'm not an authorized training partner, and this is not an instructor-led training. So if you feel like this is, you know, either one of those two things, then I'm sorry to say it is not. I'm not an expert in Pega. I'm trying to learn it, myself. So it's going to be a process for me to get through it. So um, I will give you recommendations, and I would suggest that you try to uh, work on said recommendations. But um, you know, uh, you know, I might be able to answer some of your questions if you post them, but there might be some questions that I might not be aware of. Okay, I might not have the correct answer for you. Okay, so I will do what I can, especially if you're like, with me right now in chat and during the stream and you're wanting to ask me these questions, then I will try my best to answer them. Um, but if you want to, feel free to leave a comment on the YouTube videos when, I do have them public. Um, ask them there, and um, if I can't answer them, then I will see what I can do about finding someone that can. Okay, whether it's, you know, I'll see what I can do about contacting someone at Pega to, look at the question, send the question to them or something like that. I don't know. Um, but, um, you know, I will do what I can to help you out with those questions in the comments. Don't be afraid to ask them. Okay, don't be afraid to ask questions because believe me, asking questions can lead to understanding, and understanding will help you pass your certification and a better knowledge of the material at hand. So don't be afraid to ask any questions. Okay, um, you know, um, if you were to go to the instructor-led training, I would hope that you would have someone, from Pega that knows it, you know, forwards and backwards. Okay, they know everything there is to know about Pega, and they will be able to answer your questions. Okay, with the amount of money that you spend on said instructor-led training, I would hope that would be the case. Okay. Um, so, uh, as I mentioned before, you know, when I was with a particular um, set of people trying to learn Pega from supposedly an authorized training partner, we didn't necessarily get the best result out of that. Many of us went to self-study, myself included. So, um, yeah, it wasn't necessarily the best. But then again, like I mentioned before, it wasn't necessarily someone directly from Pega that was doing that teaching. So like I said, I would hope that instructor-led training would be better for you overall. So, but with that being said, let's go ahead and get into the different missions. As I mentioned before, business architect is basically the system architect, for the two missions, and then you got two separate modules after that. These 26 modules and 23 challenges does not cover these two modules here. So after we're done with the two missions, I'll cover these two modules for those of you that are part of the business, and then I'll go on to the system architect and finish that off. I may proceed on to senior system architect because I've heard this gives you a more in-depth knowledge and might be helpful for the system architect certification. I don't know. That's what I've heard. Um, so, um, but the certification is an easy, not an easy process. So um, don't take it lightly. All right, on that. So, okay. Um, we are currently in the low code app builder extended. So, and we are getting near the end of that. So, one second, I need something to drink here. There we go. Alright. Alright, so we come on down here. We're getting closer and closer to the end. So we have the calculating fields, both the module and the challenge, and the module inviting users to the application and the challenge creating users and roles. So we just got four more before the mission exercise. So with everything all said and done, that would probably put it. The exercise would most likely be on the 24th. So, most likely. We'll see. We'll see what happens. But, um, just based off of the timing of it all and the like. But we're going to be moving on to decision tables, 15 minutes, which I doubt that will be the case. We'll probably need more than that. Um, and we'll see what we can do. So, decision tables. If you're asking a yes or no question when using an automated decision process, such as does this purchase order require additional approval, when a when rule serves the purpose. However, if you need to test the values of multiple properties to answer questions, such as what promotion offer should the company offer, you can use a decision table. So if it's a yes or no, you can just use the a when rule. Okay. If it's yes, you do this. If it's no, you do that. Okay. Decision table is, something one after another. So, for example, You can configure a decision table to determine the discount for customers at different spending thresholds. Using the decision table, customers who purchased more than $1,000 in the previous year and have been a customer for 5 or more years are entitled to a 20% discount for purchases greater than $50. Customers who purchase more than 1,000 but have been a customer for less than 5 years are entitled to a 15% discount on purchases greater than $100. Customers who do not meet either condition are not entitled to a discount. So basically, what they're saying is, you know, here's the decision table, right? So, if their previous years are over 1,000, then they satisfy both of these potential discounts, right? The difference is you know, if the customer, has been with the company or, with, has been a customer for 5 or more years, you know, then they get this 20% off discount code. Okay. If they've been a customer for less than 5 years, you know, uh, it could be, 4 months, 12, 4 years, 12, well, 11 months and, 25 days or something like that. It could be just as close to the borderline as that. Okay. Then that would, they would fall into this particular category here, and they would only get 15%. Okay. Um, if they don't match either one of these, then they don't get a discount. So the following video describes the structure of a decision table and how decision tables evaluate information. Okay, we're just gonna go through the video transcript, you know, um, because I mean, you won't be able to hear it, so you know what? I'm just gonna go ahead and um, kind of read through this myself. So a decision table consists of a table of conditions and results. You define a set of conditions, for example, property values that must fall within a certain range, and the results to return when the conditions are true. Each set of conditions contains a corresponding result. You can add columns for each condition you want to test against, either a property reference or an expression, and rows for each combination of conditions you want to test. When the system evaluates a decision table, it starts with the top row and evaluates each condition in the row. If all the conditions are true, the system returns the results for that row. If not, it advances to the next row and evaluates the conditions in that row. If none of the combinations returns a result, the system returns the otherwise result at the bottom of the table. This ensures that the decision always returns a result. So, um, so, this this table will always return a result no matter what. Okay, discount, one of the discount codes or none. Okay, so if you have like 4 different rows here, like say you have, one for customer, you have the customer history, right? Um, like maybe you have some additional discounts for customers that have been with um, um, like maybe they haven't like spent like 1,000 for the entire year. Maybe they've only spent like $100 for the entire year. So you get like maybe a 10% and then maybe a 5%, right? So maybe you want to do like, 2 more rows here where it's like, uh, greater than 5 years and, $100 spent, then maybe a 10%. Or, if they're less than 5 and less than, but they spent more than 100, then maybe they'll get a, um, 5% or something like that. you know, who's it all depends on, what you want to do in that decision table. So, uh, one major difference between decision tables and when conditions is that decision tables can return results other than true and false. Well, I mean, yeah, actually, that would be true. Um, I mean, when conditions could also return, if I'm not mistaken, when conditions can also return results that aren't necessarily, true and false. If one, like, say, I'm going to return true, it might say something like, hey, I'm going to return this result, which is true, or something, that kind of thing. So, I don't know. Maybe I'm just reading that wrong. Decision table logic. Decision tables are a great approach when you use a set of properties or expressions to arrive at a decision. In the following example, a banking application uses a decision tree for determining monthly maintenance fees. To find the correct fee, the decision table compares the account type and the customer type property values on the table and the input values to the input values. The table has rows for evaluating the correct fee for each combination. For instance, if the account type equals checking and the customer type equals basic, then the system returns a value of $10. The following example shows how the decision evaluation works based on the account type and customer type property values. So, um, so if you are a student and your account is a checking, then you get a fee of $5. Um, if you are a customer type of basic and you have a savings account, then your fee would be $3, so on and so forth. So that's basically what the decision table would kind of be like working on. Is the customer type basic? Yes. Then check the account type, and based on an account type, you'll get the fee accordingly. Based on checking or savings. If not, then they're a student customer type. So once again, you check the checking savings, and you'll see, do they get five? Do they get two? So on and so forth. So by default, a condition uses an equal comparison operator as configured in the previous example. If you're using numeric conditions, you can also specify greater than or less than comparison operators. For example, you can create a condition so that if the savings account balance is greater than $1,000, then the customer is not charged any fees. You can also use value ranges to define the comparison. For instance, if the savings account balance is greater than $500 but less than $1,000, the customer can only be charged a checking account fee. Okay. Decision tables in App Studio. You can configure calculated fields using out-of-the-box basic functions and simple custom expressions in App Studio. For example, in the online grocery application, you can use an expression to multiply the quantity by the unit price to calculate the total cost of an item. For complex calculations, which involve multiple conditions with varying results based on the conditions, you can configure a calculated field that references an existing or custom decision table. Complex decision tables that are pre-configured in Dev Studio and marked as relevant records are available in App Studio for citizen developers to use. All right. Consider the example of Y Plus Cargo Courier Company that charges a $500 delivery charge for courier services. Y Plus has decided to update delivery charge calculation based on distance. Suppose the delivery address is within 100 miles. In that case, the delivery charge is $50. If the address is within 500 miles, the delivery charge is $100. If the address is within 1,000 miles, the delivery charge is $250. If the delivery address is farther than 1,000 miles, the delivery charge is $500. You can configure the calculated field that references the decision table described below to determine the delivery charge. So distance, specify condition. Specify a condition for the decision table to evaluate by adding a column. In this example, there is one condition. Distance is less than or equal to. Table rows. Specify the table rows with values to evaluate the distance property. For example, the condition specified in the first row evaluates whether the delivery distance is less than or equal to 100 miles. So if it's less than 100 miles, you get the 50. If it's more than 100 but less than 500, it's 100. If it's more than 500 but less than 1,000, it's 250. Otherwise, it's 500. Okay, condition variables. Specify the appropriate delivery fee as a return value when the first row is true. For example, if the delivery distance is less than or equal to 100 miles, the first row is true and the decision table returns a delivery fee value of $50. So if none of these are true, false, 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 then it would have to be the 500. So otherwise, in the otherwise row, specify the value that the decision table returns when no higher row evaluates to true. For example, if delivery distance is greater than 1,000 miles, the decision table returns a delivery charge value of $500. Menu. Click the menu icon to save the decision table to a library for reuse. Okay. Check your knowledge with the following interaction. If the decision table fails to return a result for any of the testable rows, which of the following occurs? The decision table returns an error. That's not correct. The decision table returns the result of the first row. That's also not correct. The decision table returns null. Not correct. The decision table returns the result of the otherwise row, which is correct. Okay, now here's the thing. Here's what I will kind of put down though. Okay, can put down in the otherwise row an error or a null? Can't that also be true? Can't that also be a possibility? Okay, sure, you have to return the otherwise row, but who's to say that you can't return like a null or an error? So, like, if you're going through, like, your application, encountered a problem and you're, going through like, different scenarios or something like that, like, hey, um, did you have a memory error or something like that? No? Okay, move on to the next one. Um, are the buttons not working or something like that? Here's this error or something. That kind of thing, right? You could have like, multiple different errors, and then, at the very bottom, you could have like, hey, I'm just gonna return like, you know, um, this is a error at this particular location. There's nothing else that we can do about it at this time. Blah blah blah, right? So could that not also be possible? I wanted to say no. I could see that as a possibility. But obviously, you have to choose the correct answer out of all this. Okay. You know, could the decision table return null? Could it return an error? I don't see why not. But you want to make sure that, if you see the otherwise row, you know, especially for this kind of a question, that's the one that you want. So, all right. So, we are with 4 questions here, 15 more minutes left on our study session here. So, now the decision table is a fairly complex matter. Okay, you're testing a condition, and if it passes, if the condition is true, then it sends the result. Okay, if it doesn't, it moves on to the next row, and then the next row, and the next row. I mean, your decision tree or your decision table could be as many rows as you want. Okay, one would hope that you'd be able to get to a certain answer at the very end, but um, that's to say, um, how many would you really need depending on the scenario that you're trying to work out. So, all right. Drag each configuration option from the bottom to the description that would best automate the decision. In an online grocery store, customers receive an extra 10% discount if the purchase amount exceeds $300. You don't need a decision tree just for that, so you can just use an expression for that. Before submitting a purchase order, the shipping cost is calculated based on product availability and the fulfillment warehouse location. I could see that. Actually, Actually, hold on. You could still do that with a decision table. Not a very large one, but you can use it as a decision table. Um, I'm not 100% sure with this one. Okay, this one sounds like an expression. In the loan processing application, the installment is calculated based on the amount borrowed, which is a single amount, the annual interest rate, which is again a single amount, and a period opted by the user, again another single amount. So you don't need a decision table for that. So in a flight book application, the airline ticket price includes a base fare, single amount, fuel charge, single amount, tax, single amount, and meals, fairly single amount. So that should also probably be an expression. Um, I can see you using a decision table on this. Okay. Um, based on warehouse location, for the most part. I mean, product availability, if it's not there, it's like, why would you even show that product available, right? So, yep, okay. So that's, yeah, you have to sometimes take a step back and look at things again, so don't be afraid to do that. So, an e-care automobile company uses a decision table to evaluate the Express Gold battery warranty discount off the repair price based on when a customer originally purchased their battery in US dollars. Axe purchased an Express Gold battery from the e-care company 25 months ago. Due to some minor issues, the battery needs repairing. The total repair cost is $100. Because the battery is under the warranty period, what is the total due after the applied discount? Okay, so um, the Alex purchased the battery from the company 25 months ago. Okay, um, so he purchased it, 25 months ago. It was the Express Gold. So um, so he would get a return of $45. Um, okay. Because the battery is under the warranty period, what is the total due after the applied discount? Okay. Got to be careful with the language here there, folks, because he's getting a return of $45. Okay. It's not it's not something like, he's getting um everything, he's this is what he's getting back, right? It's not that. Okay. This is the discount. At least I would hope. So what is the total due after the applied discount would be 55. Okay. So Alex purchased the battery 25 months ago. As a result, the third row of the decision table evaluates as true. This one right here. And it returns a discount of $45 off the 100, resulting in a total of $55. Okay. Um, I've gotten caught on that question before. Okay, you have to really read the question. You have to really read, what they're trying to ask for. Because I would look at this and go, oh, okay, here's the 45. You know, you're getting back $45. Okay, here's your total due, $45. It's like, nope, nope, not quite, not exactly. So, all right. The U Plus Bank uses a decision table to recommend a credit card based on customer status. Ryan applies for a credit card. He's an existing customer, is 32 years old, and has a credit score of 600. 600. What type of credit card is recommended? Okay, so let's see. Does he apply, and does he, um, you know, we're gonna go row by row here. So his age, 32, greater than 30. You know, that's true. Existing customer, yep, that's true. Existing customer, he's always going to be true. So we can kind of skip that. Okay, but his credit score is not over 700. Okay, so we can't do this one. Is he older than 25? Yes. Is his credit score over 500? Yes. So he would get the gold rewards card. Okay. He would also apply, be able to get the reward plus card if it wasn't for the fact that he would get the gold rewards card to start off with. Otherwise, he would just get the standard card at the very end. So, um, all right. Each row of the decision table consists of one or more testable conditions organized into columns. How does Pega platform determine when to return the specified result for a row? When the first condition in the row is true. Um, no, you'd probably want to have, you want to make sure that your entire condition is true, not just the first condition. You know, well, okay. It all depends on how you evaluate the condition. Is the condition an or statement? Like, you have first condition or second condition. If that's the case, then then this would be true if it's an or situation. If it's an and, this doesn't can't work. So we can't, you know, uh, we can't confirm that. Um, so that's not always going to be true. That's not always going to be an acceptable condition. So when any one of the conditions in the row is true, again, it might require all the conditions to be true. So any one might not necessarily work depending on what you have. So again, this might be fine for certain conditions, but not for all. So when the last condition in the row is true, same problem as the first one up there. So, um, we can't state, hey, this is the exact, this works perfectly fine. It's like this is the same kind of problem that we have with that first one. If that first condition is also true, then I mean, I guess that's fine. But if it's false, and if it's a and condition, then well, guess what? That entire condition would be false. So that this doesn't work. So when all the conditions in the row are true, that's the one that you want. So module quiz is done, and 100%. There we go. Okay, so that's it for calculating fields using decision tables. This is not an easy topic if you're not used to it. Okay, so if you have questions, feel free to ask. Okay, I'm actually, I feel fairly, confident in those decision tables. So if you have, any questions concerning them, feel free to ask. Okay, whether it's, on stream, in the comment section, what have you. Okay, so, um, you know, so feel free to ask those questions. I'll be there to try to answer them for you. But that's it for today's Pega um, instruction video, I guess you might say, or my working towards the end goal. Tomorrow will be most likely working on a decision table, calculating fields using decision tables in the challenge. So you'll kind of see the decision table firsthand on that. So um, if you're not quite sure exactly what happens with the decision table, then I would highly recommend, um, putting in some additional decision tables in there just to kind of mess around, see what can be possible or something like that. Like for the insurance, for example, like um, maybe you want to make a decision table based off of the car that they drive, right? You know, maybe you have certain discounts for um, like one particular brand or something like that. Like maybe a brand has a special deal with the insurance company. Like, hey, we're always going to give our customers a 5% discount. So, if they're driving the Ford, giving them that 5% discount or something. That kind of thing, right? So, you'd want a decision table to kind of um, look at a customer's input and then um, help them figure out like what kind of discount would they earn, right? Now there's a slight problem with that though that you're probably gonna need to be careful with, which is um, if a customer is typing out the the answer, they might not spell it correctly. So if that happens, then they might not get that 5% discount because maybe they misspelled Ford or something like that. Like maybe they were trying to type it out and they hit C instead of the D. Okay. So, um, so because of that, you know, they might still have like the correct car, they might still have the Ford, but because they misspelled, that might be a problem. So now you need to kind of evaluate your application and see if it works, you know, see what bugs you might encounter. So, um, but that's going to be it for this session. Um, I need to use the restroom here real quick. So I'm going to go ahead and stop the recording right now.